In this video, we're going to talk about ways to prove that lines are parallel if you don't already know that you have parallel lines. And it's super important because sometimes you might want to use some angle relationships like alternate interior angles being congruent or same side interior angles being supplementary, but you can't because those angle relationships are only true when you do have parallel lines. So you can actually prove lines are parallel, and we have a couple ways to do so. So the ways that we can prove lines are parallel, and one of these is enough to prove the line's parallel. You don't have to prove all of these. One is enough. So if you can show corresponding angles are congruent, then that's enough to prove lines are parallel. If you can show alternate interior angles are congruent, that proves lines parallel. If you can show alternate exterior angles are congruent, then that proves lines are parallel. If you can show same side, also called consecutive, interior angles are supplementary, that proves that lines are parallel. Or if you can show that two lines are perpendicular to the same line, then that means that they have to be parallel as well. Because any two lines that are perpendicular to the same line, so if these two lines, if they're perpendicular to the same line, then that means that they're parallel. So let's take a look over here at the first example, and let's see how we can fill in the chart. So it says if angle 1 is congruent to angle 5, then we can say that line A is parallel to line B, and see if you can pause the video and think about the reason why. And it's because we have corresponding angles that are congruent. So I don't have a lot of room here, so I'm not going to write out fully, but what you should write is if corresponding angles are congruent, that proves lines parallel. Then for the next one, we have angle 4 congruent to angle 6. And that, once again, proves that we have parallel lines A and B. And that's because they are alternate exterior angles. And your full reason should be if alternate exterior angles are congruent, that proves lines parallel. And then we have angle 2 congruent to angle 8. And this, once again, shows that we have parallel lines, and that's because those are alternate interior angles, and your full reason should be if alternate interior angles are congruent, that proves lines parallel. Then it's saying if angle 2 plus angle 5 equals 180, well, that's another way of showing that we have parallel lines, because those are same side interior angles being supplementary. If same side interior angles are supplementary, that proves that lines are parallel. Angle 2 and angle 4. Well, that doesn't prove the lines parallel. Angle 2 and angle 4 are just vertical angles. So that does not prove the lines parallel. And finally, we have A is perpendicular to C. And B is also perpendicular to C. If that were true, that would prove the lines parallel. Because two lines perpendicular to the same line are parallel. If both A and B are perpendicular to the same line C, then that would prove that A and B are parallel to each other. Let's take a look at this first proof over here. So we're given that angle 3 and angle 8 are supplementary. So I'm going to put that here as the given. Angle 3 and angle 8 are supplementary. That's given to us. And we're proving line A is parallel to line B. So we can now say that actually. And the reason for that is if same side interior angles are supplementary, then lines are parallel. Moving on to the next one, we are given that angle 1 is congruent to angle 2. And we're also given that angle 1 is congruent to angle 4. So I'm going to write that down. Angle 1 congruent, oops, my screen's moving around, to angle 2. And angle 1 is congruent to angle 4. And that was given to us. And we need to prove that DE is parallel to GF. So first, if I know that angle 1 is congruent to angle 2, and angle 1 is also congruent to angle 4, since angle 4 and angle 2 are both congruent to angle 1, that means that angle 2 and angle 4 have to be congruent to each other. And that's the transitive property. If two things are congruent to the same third thing, then they have to be congruent to each other. So we have just shown that angle 2 is congruent to angle 4. And angle 2 and angle 4 are alternate interior angles. So that proves the lines are parallel, because if alternate interior angles are congruent, then lines are parallel. Next, they're telling us that angle DEG and angle GEF, so this angle and this angle, are complementary, and that means that they form a 90-degree angle over here. And they're also telling us that DE is perpendicular to DG, which means that where DE and DG intersect, a right angle is formed as well. Let me write down the givens. Angle DEG and angle GEF are complementary. And then we also have DE is perpendicular to DG, and that's given. And our goal is to show that DG is parallel to EF. So since DG and EF both form a right angle with DE, we're probably going to be using the reason that two lines perpendicular to the same line are parallel. We already are told from the givens that DE is perpendicular to DG, but we don't know that DE is also perpendicular to EF. So we are going to have to say that. So first, I'm going to put down what we concluded, that we have a right angle at angle DEF. So angle, DEF is a right angle. And I'm going to put over here for my reason, two angles that are complementary form a right angle. And now we can actually say that DE is perpendicular to EF. And the reason for that is perpendicular lines form right angles. So since we showed that a right angle is formed, we now know that the lines are perpendicular. And so finally, we can say that this proves the lines parallel, because two lines perpendicular to the same line are parallel. In our proof, we were given that DE was perpendicular to DG. And now we just showed that not only was DG perpendicular to DE, but we also showed that EF was perpendicular to the same line DE. So once again, since DG and EF were both perpendicular to DE, that means that they are parallel to each other. Oops, I put the parallel markings on the wrong angles. DG and EF were the lines that were perpendicular to DE. So they're the ones that are parallel to each other. Moving on over here, we have angle 1 is congruent to angle 9. So here's angle 1 and here's angle 9. And we have angle 9 is congruent to angle 15. So here's angle 9 and here's angle 15. And our goal is to show that A is parallel to B and that C is parallel to D. Already, I'm seeing that we can prove that we could prove C is parallel to D, because angle 1 and angle 9 are corresponding angles formed by line C and line D. And we can also show that A is parallel to B because angle 9 and angle 15 are alternate exterior angles. So since they're congruent, that proves that those lines forming them are parallel. So I'm going to put this all down over here in the proof. Angle 1 is congruent to angle 9. Angle 9 is congruent to angle 15. And that's given to us. And then I'm going to put from angle 1 being congruent to angle 9, we can prove that C is parallel to D. And our reason for that is if corresponding angles are congruent, lines are parallel. And then we can show that line A is parallel to line B because they're alternate exterior angles. And if alternate exterior angles are congruent, if alternate exterior angles are congruent, then lines are parallel. Moving on to our next proof over here, we have angle 1 is congruent to angle 2, and we have angle 4 is congruent to angle 5. And our goal is to prove that RS is parallel to PQ. So I'm going to just set up our statement reason chart really quickly over here. I'm just going to write S for statements and R for reasons. So I'm going to put over here angle 1 congruent to angle 2 and angle 4 congruent to angle 5. So that is going to be given to us. So our goal is to show that RS is parallel to PQ. So let's think about how we can get there. I need some way to relate the relationship between angle 1 and angle 2 to the relationship between angle 4 and angle 5. And now I see it. Angle 2 and angle 4 are vertical angles. So they're congruent. Our reason for that is intersecting lines form congruent vertical angles. So now, since angle 1 is congruent to angle 2, and angle 4 is also congruent to angle 2, so angle 1, angle 1 and angle 4 are both congruent to angle 2, that means angle 1 and angle 4 have to be congruent to each other by the transitive property. If two things are congruent to the same third thing, then they have to be congruent to each other. And now, if angle 1 is congruent to angle 4, so angle 1 is congruent to angle 4, but angle 5 was also congruent to angle 4, well, that means that angle 1 and angle 5 have to be congruent to each other by the transitive property as well. And now that we know that angle 1 and angle 5 are congruent to each other, angle 1 and angle 5 are alternate interior angles. We showed that they're congruent, so that proves that the lines are parallel. If alternate interior angles are congruent, then lines are parallel. Here we're told that angle 1 and angle 3 are supplementary to each other. So angle 1 and angle 3 are supplementary. And our goal is to prove that P is parallel to Q, that line P is parallel to line Q. So angle 1 and angle 2 are vertical angles. So I'm going to put that down into my proof. So first let me put the givens. Angle 1 and angle 3 are supplementary. This means that they add to 180 degrees. And then angle 1 and angle 2 are congruent because they're vertical angles intersecting lines form congruent vertical angles. So that means since angle 1 and angle 2 are congruent, that means that angle 2 and angle 3 have to be supplementary. And that's by substitution, because if angle 2 and angle 3 were supplementary, and now we know that angle 1 and angle 2 are the same, then that means angle 1 and angle 3 have to be supplementary because angle 1 and angle 2 are equivalent to each other. So now we know that the lines are parallel because angle 2 and angle 3 are same side interior angles. So we showed if same side interior angles are supplementary, then lines are parallel. In the next one, we have that angle 1. Oh, this is just doubled again. Sorry about that. That was the same proof. Here we're given that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Let me start making my statement reason chart. I'm just going to write S for statement and R for reason to save some space. So we have that angle 1 is congruent to angle 2, and we have that angle 2 is congruent to angle 3, and both of these are given. So already from the givens, I can see that since angle 1 and angle 3 are both congruent to the same angle 2, then that means that they have to be congruent to each other. And that is by the transitive property. Angle 1 and angle 3 for line A and line C, those are alternate interior angles. So that's how we can prove part C that A is parallel to C, because we have congruent alternate interior angles. The first step was to prove that A is parallel to B. Angle 1 and angle 2 that were given to us, those were already alternate interior angles for A and B, so that proves that A is parallel to B. So I'm going to put this down into the proof because we already have enough information. I'm going to just go in the order that it says to prove it in. So A is parallel to B if alternate interior angles are congruent, then lines are parallel. So that is angle 1 and angle 2. Those are the alternate interior angles formed by line A and line B. And then we have A is parallel to C. And that's once again due to the alternate interior angles, but the alternate interior angles that we show they're congruent that are formed by A and C are angles 1 and angle 3. So if alternate interior angles are congruent, then lines are parallel. And then finally, we need to show that angle 3 is congruent to angle 4. Well, now that we proved that lines A and C are parallel, angle 4 and angle 3 are corresponding angles formed by A and C. So I'm going to put that over here. Angle 3 is congruent to angle 4 because if parallel lines are cut by a transversal, which they are, we already proved that A was parallel to C. So that means corresponding angles are congruent.